All right, chemistry kids, here we go. We're in Unit 7, Stoichiometry. As you can see, it is the math behind a chemical reaction. So yes, there is more math involved in chemistry. There is actually a lot of math involved in chemistry, if you haven't figured that out yet. But now this is specifically how to move from like products to reactants, reactants to products, using ratios and dimensional analysis, which are things we talked about before. All right, so hopefully this kind of ties everything together. It's not really it's new stuff. It's the fact that we're putting everything together and making it useful for chemistry. So how we need to think about this in terms of what you need to know to start off with is definitely vocab, because when I'm talking in class and we're doing stuff in labs, when I say certain words, you might not know what I'm talking about. So if you know these vocab terms and how they pertain, it'll help out a lot. All right, so let's look at this reaction right here. This is a single replacement reaction. Why is it a single replacement reaction? Because you start with an element and a compound and you make a new compound and a new element. All right, remember Cl2 and Br2? They have a 2 next to them because they're the sneaky 7 or the diatomics, so that means when they're by themselves, which is what they are here, they have to have a 2 next to them. All right, so there's our reaction. The first thing I would say is a balance, which you need to always check to make sure it's balanced. In other words, do you have the same number of elements or atoms on each side of the arrow? All right, so here Na, we have 1 here, we have 1 Na there, that's good. We have 1 Br here, we have 2 here, so we need to change the coefficients. Remember, the coefficients go in front of the formulas. So now we have 2 Brs and 2 Brs, but now we need to recalculate and we need to have 2 Nas. We need to put 2 Nas here, put it in front. Remember, you can't split the compound. Now we have 2 Nas and 2 Cls, 2 Cls. Now we have a balanced chemical reaction. And it's imperative to have a balanced chemical reaction. All right, so when it's balanced, we can figure out the mole-to-mole ratio of compounds to each other, or moles to reactants, or reactants to products, things like that. All right, so the mole-to-mole ratio is basically determined by a balanced chemical reaction. So what's my mole-to-mole ratio, say, of chlorine to NaCl? Well, the mole-to-mole ratio, you go by the coefficients. So it's a 1:2 ratio. All right? And this is going to be useful for when you're converting things like from grams of this to grams of that. You need to have that mole-to-mole ratio to convert from one to the other, because you know how many moles of one thing versus the moles of the other. So we have a 2-to-1 ratio, whereas if we had the mole-to-mole ratio of chlorine to bromine, it's a 1-to-1 ratio. Notice the coefficients, 1-to-1. All right, they're not written, but they're understood. And then a 2-to-2 ratio between NaBr and NaCl, which would just reduce down to 1-to-1. And then a 2-to-1 ratio, and so on and so forth. So the mole-to-mole ratio is basically the coefficients of a substance compared to, compared to another substance. So example, what's my mole-to-mole ratio, say from Cl2 to NaCl? Oops, you can't see that. There you go, NaCl. Well, it's a 1-to-2 ratio. All right, so where did this 2 come from? Came from here. Where did this 1 come from? Came from here. So keyword, the coefficients. All right. Now, limiting reactants and excess reactants and things like that, here's what goes on with those. When we start talking about limiting reactants, this is going to be the lesser amount produced. Okay? This is going to be the greater amount produced. So when we do our calculations, there is going to be a lesser and greater amount produced when we deal with limiting excess reactants. The limiting reactant limits how much you can make, hence it's called a limiting reactant. The excess reactant is what you have left over. All right? So this is going to be limiting, in other words, it's going to be the lower amount, and this one's going to have, you're going to actually have extra of this stuff. Another terms we need to know: actual yield versus theoretical yield. Well, actual yield is basically say how much you actually get. You really produce. Whereas the theoretical yield is how much you should produce. Okay, and just so you know, this would be like how much you get in the lab versus how much you actually calculate. All right, so this would be a calculation you would do, and this would be like, say, they might give this to you, or you might say in a lab, I got, 10 grams when I should have got 11 grams or something like that. All right, percent yield is comparing the actual versus theoretical yield. All right, so percent yield is how much based on comparison. So it's basically the percent difference the percent difference of actual versus the theoretical. Are we getting there? Yep. Okay, of actual versus theoretical. All right, so there's a percent difference. And there's a formula that's going to go with this, which we'll talk about later. And the whole big picture, stoichiometry, on the bottom here, I'm not going to write it down, but I'm just going to tell you. Stoichiometry is basically the whole how the products and reactants relate to each other in a chemical reaction, mathematically speaking. So you're going to see mass and moles and grams and particles and liters and all that kind of stuff go on here. But really the stoichiometry is the calculations that are involved with a chemical reaction. And they're going to be involved with the mass calculations, the mole calculations, the liters calculations, the particles calculations. It's all going to be in there, all right? So these terms should help you out as we get through this stuff. Make sure you guys check out your book, your online book. Here's the sections. You guys can read about it extra and look at things extra. I do have some extra videos too. But there's your first introductory unit. This might not make sense right now, but keep these handy as we go through the unit. You'll be like, okay, I remember that term. I heard that term before. And then look it up and it'll help you out. All right, so hope this video helps. We'll talk to you guys later.